in chapter 6, we learned a bunch of exponential properties. Things like if you have exponents that have, or bases that are the same and they're raised to exponents, you can multiply those two things together and there's a shortcut. Do you remember what the shortcut is? What do you do to the exponents?
Add them.
Yeah, you add them. Okay, that gives you x to the 8th. That is a property of exponents. It's a property that's easy to understand usually, but it is a property that is unique to exponents, that is different than, say, like real numbers. With real numbers, you just like essentially count stuff up when you add it, and it's like common sense, and you can wrap your head around it. Logarithms are going to be probably the first type of math that have special properties that you might not be able to wrap your head around completely. The product property of logarithms, which is this first one, number 1, comes from this property. It's just that since logarithms are inverses of exponential things, we'll say, that it looks kind of backwards, but it's the same idea. So with logarithms, if you have the product, let's say 2 and x, a logarithm of a product of two things, 2 and x, I can split that up into two logarithms, the log of 2 plus the log of x. I can also go the other way. If I have two logarithms and they have the same base and they're being added, I can put those together as a product, which is essentially what we're doing here, just different because it's got logarithms in it. We had other, yeah, it's like you're undoing it. We had other properties over here. We had one that, we had one that involved a quotient. Do you remember what the rule was here? X to the 5th over x cubed. What do we do? Yeah, you subtract. Same thing with logarithms. If you have a quotient, let's say 2 over x, I can split that up. Instead of one logarithm of a quotient, I can split that up into two separate logarithms with a difference. Or if I have the difference of two logarithms, I can put those together. I would just put whatever came first on top and whatever came second on the bottom of a fraction. Yeah?
Do the bases have to be the same?
Yes, the bases have to be the same. So I'm not writing bases, which means my base is what? 10. But yes, if one's like a 2 and one's a 3, you're not allowed to do this. You just do nothing. You just leave them alone. Same with if it was like x to the 5th and y to the 3rd, what do? You nothing. You just leave it alone. Can't do anything with that. There was a power rule. What do you do when you have something raised to an exponent raised to another exponent?
Multiply.
Exactly. This looks a little different with logarithms. So a log of, say, x to the 5th is equivalent to 5 logs of x, or 5 times log of x.
Well, that makes sense.
Could make sense. Makes sense when you look at them with numbers instead of letters. So if you look at it like log base 2 of 8, 8 is 2 cubed. And if I rewrite this using that property, that's 3 times log base 2 of 2. And log base 2 of 2 is 1. So you get 3 if you were to simplify that. So if you use the property, you get 3. Otherwise, if you just evaluate this, 2 cubed is 8. And so this is 3. So it makes sense. There's one more thing. And it's the fact that anything to the 0 power is 1. Now with logarithms, there is no log of 0. So any log of 1 is 0. So again, it's like the backwards version of that. So any logarithm of 1 is 0. Okay, so if you look at the left, that should be stuff you know. If you look at the right, this is new stuff. Hopefully you can see how they kind of relate to each other. If you don't know any of this, that's bad. That means you forgot everything and you need to like fix that. A lot of people, if you were talking to first period or third period and they said this was hard, the reason it's harder than it has to be is because many people have forgotten what we did last semester, which is why I told you not to throw out your notes. You can't just forget stuff in math. You have to remember exponential properties. You have to remember that this means the square root of 4. Like, there are things that you guys have to remember, and if you've forgotten them, then yes, this is going to be very hard. If you remember them, it's still going to be hard, just less hard. Okay? I'll be here after school, and I'll be here in the morning if you want help. So the first thing we're going to do is, we have multiple logarithms here, and we're going to smoosh them together. We're going to condense them. So we want to express this as one logarithm instead of 2 or 3 or whatever. So smoosh. Step 1 is you're going to check to see if any of the logarithms have a number in front of them. So you're just going to check. Do you see logarithms with numbers in front, like multipliers? No, but you want to check that first, okay? Because we would want to take care of that first. So that's like step 1 is you're looking for those. So we don't have that. So step 2, you're going to check the sign in between. Is it a plus or a minus?
Plus.
It's a plus. If it's a plus sign, that means we're allowed to use the product property of logarithms, which says if we have 2 logarithms with the same base, which we do, we can take these 2 and multiply them together. And after we multiply them together, we will have condensed that into one single logarithm. So instead of log base 4 of 5x plus log base 4 of 3x, we just have one logarithm of 5x times 3x. So again, this is like not really intuitive. You would maybe think, oh, I can just add 5x and 3x and get 8x because there's a plus sign there. Wrong. You must multiply them. When we multiply them, sometimes you just put them next to each other, but other times you can actually simplify. So in this case, we would probably multiply your 5 and 3, get 15, multiply your x and get x squared. So we have log base 4 of 15x squared.
That'd be the final answer.
As long as your logarithms have become logarithm, then you're good. So you want to take multiple logarithms and you want 1 at the end. If you still have more, you're not done. So it's a good beef. We have 2 logarithms. We want 1 logarithm. Remember I said step 1 was to check for the power, check to see if we can use the power property. So do we have any multipliers?
Yeah.
Yes. We have a 6 and a 5 multiplying our logarithms here. So what we'll do is we're going to turn those into exponents instead. So the 6 is going to become an exponent of x. Like so. And then the 5 is going to become the exponent of y.
I see.
Does that make sense? Yay, nay, maybe? All right, now the next thing after you take care of the power property, you're gonna check for one of these. Do we have a plus sign or a minus sign? We have a minus sign. So if we have a minus sign, we're gonna use the quotient property, aka property 2. To use the quotient property properly, you're gonna take this guy and express them as a quotient. Whatever comes first is gonna go in the numerator. Whatever comes second is the denominator. So x to the 6th, since it came first, goes on top. And then y to the 5th, since it came second, goes on the bottom. So we have x to the 6th over y to the 5th as part of a single logarithm instead of 2 separate ones. Squish, one single.
Squeeze.
Squish. Questions?
So hard so far.
So far. This one has 3.
Ah.
Oh, that's not a. What is that? It's just a blinking cursor. Let it go away. Okay. Wait. Oh, it's frozen. It's bothering me. Oh man. Oh no. What happened? Okay, there we go. All right. So 1, 2, 3. Don't look at 1, 2, 3 like I have to do 1, 2, 3. You're gonna look at them like 2 at a time. So if there's 7 of them, please don't look at all 7 and think, ah! No, you're just gonna do like bits and pieces, a little bit at a time. Do not get overwhelmed. I won't give you 7, but I could.
Oh, great.
So, first things first, see how we have a 2 here? We're gonna turn that into an exponent.
Wow.
So instead of 2 logs of x, we're gonna have
Log x squared.
log of x
Okay, it's
squared. Okay. Okay. Next, we're gonna take them 2 at a time. So working left to right, focus on the first 2 logarithms. What sign is in between? Plus, which means we need to multiply x squared times x plus 2. So we're multiplying x squared times x plus 2. And after we do that, that will be part of one single logarithm. Now, we would probably distribute the x squared in that case, so it looks a little cleaner. So that would give us x cubed plus 2x squared. You need the parentheses, don't forget those. Okay, so those are part of one logarithm now. Now there's 2 left. Smoosh one more time. How will we smush?
minus because it's dividing. So
Quotient.
dividing.
Yes, so since it's got a minus sign in between, we're gonna express this as a quotient. Whatever comes first is the numerator, whatever comes second is your denominator. So you'll have one big quotient with x cubed plus 2x squared in the numerator and then 4 in the denominator. And so we took 3 logarithms and we expressed it as 1 logarithm, so that means we're done.
Is the base technically?
Okay, we go in a slightly different order. Typically when we're expanding, we want to first look and see if there's a quotient that we can separate. After that, we look at if there's a power we can separate, and then after that, or I'm sorry, product rather. And then after that, we look for if there's a power that we can change. So it's kind of like the backwards order of when we condense. When we condense, we usually look for the power first, and then these two from left to right. So this way we're looking backwards. The first thing you're going to check is there a quotient?
Yes.
Yes. So here is my quotient. 2x is in the numerator, y is in the denominator. What I'm going to do is instead of writing one quotient, I'm going to separate it so that it says log top minus log bottom. So log base 3 of 2x minus log base 3 of y, splitting up the quotient into 2 pieces, log top minus log bottom. Okay. After you do quotients, you shouldn't have more than one quotient, otherwise that would be weird because you'd have a compound fraction. So after you do the quotient, you're going to look for a product. You have a product of 2 and x, technically. Your goal is to get as many logarithms as it takes so that the only components to your log are a base and then one thing here. So if you have two things, like a 2 and an x, that's 2 things, that means you have a product. So you would split that up into 2 logarithms. So if it was just a 2 or just an x, you'd be done. But since it's 2x, that's technically the product of 2 and x, which means we can split this up as log base 3 of 2 and then plus log base 3 of x. And then we have this guy over here, he's just hanging.
So low storage. Why?
Now, in general, you're always supposed to simplify. So at the end of doing all of this, you're gonna check your logarithms that have numbers and not letters in them to see if they simplify to a rational number. Some logarithms simplify to rational numbers and other logarithms simplify to irrational numbers, and yuck, you need a calculator to find them. One of the things you're doing on your quiz is just evaluating logarithms like this. You need to know 3 to what power gives you 2, and that is what this logarithm is. Now, is that a rational number?
No.
No. So if it's not rational, you're allowed to leave it like that. But if it is rational, then you would keep going. So for example,
Like log 3 of 9.
exactly, something like that, log base 3 of 9. There is a power that you can raise 3 to get 9 that's rational, and it is 2. 2. And so we would
Well, I said 2.
kill that and write 2 instead, because 3 squared is 9. I know you were thinking 3 times 3 is 9. Okay? Doesn't apply here, but will apply for next one. Once we have log of single thing, log of single thing, log of single thing, we're done. Okay. Let's look at the next one. Next one is a quotient. Oh look, we have a quotient. Let us split our quotient
Oh,
up.
wait, that's just it. That's the answer.
Yeah.
So log base 9 of x to the
So log base 9 of x to the 4th minus log base 9 of 729.
That's a happy number.
Do we have a product anywhere?
No.
Yeah.
No, but we do have
A
x to the 4th,
Which
Can
is
be
a
a
power.
product.
which can turn into a product because it's a power. So we can take the 4 and push it up. So you're making everything bigger when you're expanding. So think the exponent, it was like a tiny 4. By putting it in front, I've made it a bigger 4. Okay, you're making everything bigger when you expand. You condense, you're trying to make everything small. So we don't have a product, but we did have a power, so we pulled that down. So this one is good, we have log with one single thing. This one would be good, we have log with one single thing, but we want to check if this can be simplified.
9 to the 4th, 729.
You're close, it's gonna be 9 squared is 81, and then
Oh, 9 to
9
the
cubed
cubed
is
is
729. So this logarithm simplifies to 3, because 9 to the 3rd power gives me 729. Now, I know that 9 is big, and you might not know that 9 cubed is 729, but you should know, like, 2 cubed is 8. You should know, like, most, if not a lot of 2s. You should know, like, 2 to the, like, 6th, or be able to calculate it quickly. You should know, like, 3 to the 4th is 81. You should know, like, 6, maybe cubed. You could know 5 cubed is 125. Like, these are things you should know. Like, you should absolutely know all the 2s and all the 3s. If you don't know past that, then, you know, I get it. All right, try the try. No.
No.
No. Combine
Hacking heck!
and -2 to get.
AirPods are live again.
But I have AirPods.
Okay. Now we're gonna get into the harder stuff.
Hold up, hold up.
Oh, I thought we were
Harder?
So that's it? That's our answer?
Like after that.
That's it, that's your answer.
Jeez, man.
So.
Can we call it break?
I should
Nope.
drop down.
Can we do worksheet?
No.
This is involved.
Okay,
Dang.
last one, we are going to be using our, like, quadratic skills and other kind of skills that we learned in first semester, adding those skills to the skills we learned today, and we are going to combine logarithms, and then we're gonna simplify as much as we can. So, step 1, looking at these first 2 logarithms that are separated with a minus sign, I can condense this to one logarithm with a quotient. So I would put x plus 1 as the numerator, and I would put this quadratic as a denominator.
That's a big exponent.
Like that.
You make my outro tattoo channel, YouTube channel go doing doing doing.
Ninoy, noy, ninoy.
Now, focusing on this one and this one, I can express this as a single logarithm by multiplying this fraction by x minus 2. So what you're doing is you're taking this and multiplying by x minus 2, technically over 1. So the
So it's a
x minus
binomial.
2 is going to join the x plus 1.
Making binding.
It's a trick. Send no reply.
foil that, and then keep the
Don't foil,
bottom.
don't foil.
Wait, why not? You've just been foiled.
Because then you won't be able to simplify.
Your plan
I
has been
got
foiled.
I've been fooled.
Alright,
This
now,
is-
we've expressed as a single logarithm, so we're like kinda done, but we're not done because what's inside that logarithm simplifies. So we have condensed it, okay, we've expressed it as a single logarithm, but now we need to simplify all that stuff on the inside, so this goes back to previous stuff that you know. So far, I have this inside my logarithm, and I'm gonna see if it simplifies. To see if it simplifies, you would have to factor the denominator to see if anything cancels.
Why are you making us go back to factoring? Factoring is so
It's never
last
going
year.
away, I told you that.
3x.
So in order to factor that denominator, you can take out a 3 to start. Right? Because greatest common factor, you take out a 3. And then you can factor this. What is this factor to?
X
One. X minus 2.
Yeah. Now, look at that.
That's a
Okay.
coincidence.
What cancels?
Everything.
Except
1/3.
the
So
3.
it's 1 over
What did
3.
it cost you, Nick?
So what do we have? We have 1 over 3 inside the logarithm because we simplified a lot of stuff. And so we have log base 3 of a third. 3 to what power
Hold up, I can't
is
see.
1/3?
-1.
Yeah.
Yeah.
The end.
What?
That's,
Really?
That's not a happily
This
ever
seems like a
after.
lot of work for like.
For negative
Oh,
1.
3.5.
That's just
I know,
pre-calculus
that's like
in
what
a
everyone
nutshell,
says.
Seems like why do I have to do that?
right?
I don't know.
It's just -1.
It's like every time I walk
Right,
into
it's
Mr.
like a
Harold's
complicated
pre-clap
number.
class, they're doing some weird, extravagant problem that takes up the whole
You don't
board,
have a
and then the
calculator for this
answer's
quiz, no.
always like 1 to 3.
So how am I gonna know log?
Christiane,
base
what did it
3
cost
to
you?
one
You
third
should
is
know
three.
your X. Okay.
Yeah.
We're gonna start the same way. We're gonna start condensing from left
Dude, this
to
one's-
right. Now, before we do that, remember the first thing we always check when we're condensing is we look for things that we can turn into exponents. This right here is a 1/2.
Jeez.
We would make this an exponent. Do you know what a 1/2 exponent is? Yeah.
Jeepers creepers.
Look
Right.
at those peepers.
Where'd she get this?
It's technically to the 1/2 power, but that is a square root. Again, this is stuff you need to know.
Why not Q?
Oh, I'm on this wrong page. Perfect.
Now, before I start condensing, this can be simplified and be slightly less ugly. The square, if you want to square root a quotient, you can square root the numerator and then square root the denominator. So this can be simplified to 1, because the square root of 1 is 1, over the square root of a minus 5 cubed. Slightly less ugly, still kind of not cute.
So wait, what's that arrow from 1/2 to, what's that?
That's the power property. If you have 1/2 times the logarithm, you can make that the exponent. But an exponent of 1/2 is really a square root, so I put it all in the square root. What's an exponent of 1/3? No, like what does it mean? Cube root. Exponent of 1/3 means a cube root. These are things you need to know.
East.
Okay. Now we will start to condense. Taking these two,
Condense milk.
you can multiply what's inside here together. So when you multiply the quadratic by this fraction, what winds up happening is you get a squared minus 10a plus 25 over the square root of a minus 5 cubed. The reason you get that is because this is a fraction. So when you take a non-fraction and you multiply by a fraction, you get a fraction. You take the tops, you multiply those, take the bottoms, you multiply those, and you get that. Smush again. This is a quotient, which means
It's gonna go on top
Wait, how'd you get? How'd you get?
instead of taking
Multiply.
this and dividing by this, we can multiply by the reciprocal, so 1 over this. Okay? So this product is what's gonna go inside your logarithm.
Alright, hold up. Let me write this all down on this round.
of. So a squared divided.
You're writing it in.
I mean, I am, but you're just doing stuff. I didn't know I had to do that.
Now, when you combine these things, I have 3
It's to,
square roots of a minus 5.
it's to the fourth.
And here I have 1 square root of a minus 5, and so when you put those together, you should get a minus 5 to the 4th square rooted.
That's the answer. That's your
Wait,
final.
No, not that.
Nuts. We're not
You
done,
can simplify
Andrew.
that. What happens when you square root something that's to the 4th power?
It's
Second
it's
power.
To the 2nd power.
Wait a minute. This is gonna be 0, isn't it?
Who did all this complicated work for
Okay.
zero?
Because you get top is.
When you factor the top, what do you get?
a minus 10 plus no.
When you
A
factor.
A minus 5 squared. A minus 5 squared. 1. Anything log basically 1 is 0. I'm just gonna start guessing 0 and -1.
I stopped.
That's
When
a
you
good
factor
strategy.
the top, you should get a minus 5 times a minus 5 because -5 and -5 make 25 and they add to 10. A minus 5 squared divided by a minus 5 squared is 1. And any logarithm of 1 is
0.
0.
How'd you get the bottom as a minus 5 squared?
Let me go back to this.
Dude, that's rough.
She
This,
had the square root.
when you multiply, so think of this as a minus 5 to 1. If you take 3 a minus 5s and 1 a minus 5, you get 4 a minus 5s. That's this part.
Oh, and then you have.
Then you square root that, and that gives you squared, because square rooting something to the 4th power would give you 2, and that's how we get that.
It literally was nothing.
On my quiz, I'm just